We've already done questions involving just numbers. That's like the learning goal you did today. And perimeter. Today we're doing money. Tomorrow we'll do another type. Or a couple of types even, maybe. Go ahead. We'll talk about that after. So when we're doing money, almost always, or maybe even always, we have to consider the value of the coin. That's the point of these questions. How much each coin is worth will be part of our solution. Okay, and remember when we were doing the other ones, there was always kind of two parts. You're given two pieces of information, one that makes the equation, but one that gives you another relation. Same thing happens with these. Okay, so let's give it a try. First one says Sandra has 15 coins. That adds up to $2.40. Again, watch out for your decimals. Are you working in dollars or are you working in cents? That's going to be important. If her coins are only dimes and quarters, how many of each coin does she have? Okay, what do we often start with word problems? What's our, in terms of form and the steps that we talked about on Tuesday, what do we start with? Let statements, very good. Here's a tip on let statements. It's not perfect. It doesn't always work, but it's a good place to start if you're stuck. I'm trying to find how many coins, so I'm going to let my variable be about how many coins there are. Very often, your let statements or your variables are going to represent the thing you're trying to find. So I'm trying to find how many dimes and how many quarters. What variable do you think I should use? How about D for dimes? If you can use a letter that goes with the thing you're talking about, it just helps your brain keep track of what it's doing, okay? Of where you're at and what you're doing. So we're going to say let D represent, and again, we talked about this on Tuesday, last day. We don't say let D represent the dimes. That's meaningless. So what am I going to say?
The number of dimes.
Very good. The number of dimes. The variable has to represent some number. A length, an amount, a height, which is like a length, right? It can't just represent the dimes. So represent how many dimes or the number of dimes. So if I have 15 coins in total, and I have D dimes, how many quarters do I have? We don't know the answer. It's not like the answer is 4. We don't know that. Here's another stretch. Does anybody know? Don't shout it out, but put your hand up if you think you have an idea. Okay, 1, 2 people, a couple people have an idea. Here's another tip. We don't know the answer. We're going to work it out. But let's say, what's a possible answer for the number of dimes? What might it be? Is it going to be 40? Why? She only has 15 coins. How could you have 40 dimes? And negative 25 quarters? Like, that's ridiculous, right? So, what might it be? 4. I like it. Let's say she got 4 dimes. How many quarters would she have?
8.
Why? Okay, very good. So you're using this idea. What if I scratch that out for now? What if I say, don't do that? And I have 4 dimes. How many quarters do I have? 11. Why? 15 coins in total. And 4 plus 11. How'd you get 11? Just kind of thought about it? How else could you do it? What's the operation? What's the mathematical operation that's involved there? Say again? Subtraction. 15 minus 4. If I have 15 total, 4 of them are dimes, the rest are quarters. Subtract 4 from 15, and we've got the number of quarters. So then how do I turn that into an expression? What do you think? Anybody? If the number of dimes was 4, we did 15 minus 4. So the tip here is use numbers. Try using a number and seeing how you would do it. And then turn that into a letter. So if the number of dimes was 4, it's 15 minus 4. If the number of dimes is D, then what is it? 15 minus D. Then 15 minus D is the number of quarters. Put your pencil down and watch. I'm going to show you another way that you could do that. Again, we talked about this before. Some of you might like this way better. I don't know. If the number of dimes is D and the number of quarters is Q, and I have 15 in total, I know D plus Q is 15. If I move D to the other side, the number of quarters becomes 15 minus D. Same thing. If you use 2 variables, maybe this part becomes easier for you. I don't know. But if you can come up with this expression without 2 variables, you can do it that way too. See how it's a little bit different, but it gets you the same place? But again, this is like when you're doing your practice, you have to pick a way that works. And I would say pick one way or the other and try to always do it that way. Don't kind of mix and match. You confuse yourself. Does that make sense? So we've got D is the number of dimes. 15 minus D is the number of quarters. Okay, what's next? We know they add up to $2.40. If I have D dimes, what's the value of my dimes? Yeah. So we said before you have 4 dimes. How much is that worth? How'd you get that? Multiplication. What if you had 8 dimes? 80 cents because 8 times 10. What if you have D dimes? 10D. So 10D is the value of the dimes. Okay. What's next? Dimes are worth 10 cents. Quarters are worth 25. So 25 times what? Somebody said Q. Very good. The number of quarters. What's another way we talk about the number of quarters in this question? 15 minus D. So the number of quarters is 15 minus D in brackets because it's the whole thing. Or, so this is the value of the quarters. Because this is like our Q. And that whole thing is the value of the quarters. Folks, this is like the most important thing you got to get out of today, right? You have to understand why we did this. D is the number of dimes. What if it was 4? Then the value of the dimes would be 10 times 4. 10 times 5, 10 times 6, 10 times 8. We don't know how many dimes there are. What about the quarters? That's the number of quarters. If I have 4 dimes, I have 11 quarters. 15 minus 4 times the value of 1 quarter. But this is not something that we can solve. So what do we have to add to it? Not add as in plus, but like what do we have to add on the end of this? Caleb? Very nice. And what is it going to equal? $2.40. Don't write this down. If I do this, there's something a little bit wrong with this. First of all, we wouldn't usually use a dollar sign, but there's something inconsistent in my formula. What's wrong with it? Very good. I did cents over here and dollars over here. That's not going to work. So what do I do to fix this? So there's 2 ways you could do it. Again, don't write this down. Wait till we're done. I either turn this into 240 cents, or I go back and I go 0.10 and 0.25. So everything has to be in dollars or everything has to be in cents, but you have to decide. I think it's easier than sticking in decimals here to change this to 240, so let's go with that one. We chose to do it in cents, so make sure everything's in cents. But if it's talking about $5 bills and $10 bills or toonies and fives or something like that, then you'd be working in dollars. But you got to think. Any questions? Now what do we do? Just solve it, right? Okay, go for it. So distributed property, you got to multiply 25 by 15 and 25 by D. I'm going to move the 375 over. You probably don't need my help for this, but we'll make sure that we're staying on the right track. Remember that mistake that we make sometimes where we always do the bigger number minus the smaller number just because we think that's a habit? Not how it turned out here. It's 240 minus 375. I'm moving the 375 by subtracting it. So I'm subtracting 375 over there too, right? Some people might do this. They might say, well, I'm going to subtract the 240 because it's the smaller one, but then write it on the other side. But that's wrong. You can't do that. So you really got to make sure you're moving things the right direction and you're subtracting the correct thing. 240 minus 375, who's got that? Thank you. Negative 135, right? And I got negative on both sides. That's what makes sense. Is that 9? So what? D equals 9. Who cares? What did we just find?
How many times we have?
We found how many dimes we have. And again, that's a little bit easy for us to figure out because it's a D. It wouldn't be that much harder, I know, if it was an X. But it's kind of nice that it says D. So D is the number of dimes. But we're supposed to find both. So the number of dimes is 9. The number of quarters is 6. How'd you get that? 15 minus 9. Therefore, Sandra has 9 dimes and 6 quarters. In other words, Sandra's broke. Any questions? These ones can be tricky, folks. If it seems like it makes sense, going back and doing it on your own can still be tricky. Getting to this line here requires some real understanding of how this works. But remember what we did. We call this the denomination, the value of a piece of money. So a dime has a denomination of 10 cents or 10 or $0.10. Quarters have a denomination of 25, 0.25, whatever you're working in. And we have to multiply that by the number of dimes and the number of quarters, and then we solve it. Oh, it got erased when I was erasing something else. Thank you, yeah. That would be confusing if somebody looked at it after. The 2 got erased, I think. Okay, any other questions? Good? We got one more to try. This one's a bit more convoluted, I would say. Often the ones that we do tell you how many coins they have. So it's like the first one. But again, it's giving us how much money he has in total. There's only 2 types, toonies and $5 bills. And then it tells us something about the relationship between how many he has of each. All right, what do we start with? Let statements. What do we want to let? So the number of 5s don't write this down, just watch. Let's try to do this together. The number of 5s is So 5 times the number of toonies, but it's 1 more than that. So if I take that and add 1, that will equal the number of 5s. The number of 5s is 5 times the number, is 1 more than 5 times the number of toonies. Does that make sense when you see it like that? So what am I going to make my let statement?
Let T represent the number of toonies.
Very nice. I like it. Let T represent the number of toonies. Then we've already got our expression done. 5t plus 1 is the number of 5s. Okay, and again, watch this. I'm going to do it a little bit of a different way this time, again, because I think this can be tricky. A toonie's worth $2. So 2 times the number of toonies plus $5 bills are obviously worth 5. 5 times the number of 5s. Maybe it sounds easy when you hear somebody else say it, but this is not easy. I don't think it's tricky when you're doing it for the first time. If I have 8 5s, they're worth 5 times 8. If I have 3 5s, 5 times 3. If I have 100 5s, 5 times 100. This is the number of 5s. That's how much they're worth. The number of toonies, that's how much they're worth. The worth of the toonies added to the worth of the 5s all together. All the 5s and their worth, all the toonies and their worth has to equal, in this case, $59. So everything in this case was in dollars. We didn't have to worry about cents, but you should be just aware that that's happening. What is the number of toonies? T, very good. Some people are like, well, we don't know yet. Is it 8? I don't know. Right, it's T. What is the number of 5s? Very good, 5t plus 1. That's where our let statements come in. We already figured that out. Now we can solve it. So go ahead. What'd you get? 2. If you're not all the way done, that's okay, but that's what I got as well. Very nice. Next step. Maybe you go back and read the question. What am I actually supposed to be able to find? What if the question said, how many toonies? You're done. You found it. Different questions ask different things. If it says, how many toonies? You're done. You found that. But what does our question say? How many of each denomination does Mr. Jones have? So what do we have to do? Yeah, we have to go find the number of 5s. Okay, So the number of 5s is 5t plus 1, which is 5 times 2 plus 1. Remember when we talked about substitution and how much we would be doing it throughout the semester? Almost every day, right? It comes up. And this is BEDMAS, 10 plus 1, which is 11. Therefore, Mr. Jones has 2 toonies and 11 5s. Does that make sense? Not like, does that make sense to you, but does that actually make sense? What do you think? If I have 2 toonies, how much is that worth? $4. So 2 times 2 is 4. And if I have 11 5s, how much is that worth? 5 times 11. And how much is 4 plus 55? So it makes sense, doesn't it? Take a look at this, though. We had 2 toonies. They're worth $2. We had 2 of them. I had 11 5s. 11 of them, they're worth $5 each. The toonies are worth $4. The 5s are worth $55. A total of $59. That's the same as we wrote up here. 2 times the number of toonies plus 5 times the number of 5s. We just didn't know what it was, so we were using an expression instead of the actual number. But this right here is the same as that right there, isn't it? Same idea. Okay, and it might help when you look at that to make sense of how you go back and come up with the other expression that we had above. Any questions?